Hey there, everyone! Welcome back to our channel. If you're new here, don't forget to hit that subscribe button and join our awesome community of learners. Today, we're diving into a fundamental concept in machine learning that can make or break your model: accuracy. So grab your notebooks and let's get started. But before we jump into the nitty-gritty, let me ask you this: what does it really mean for a machine learning model to be accurate? Is it just about the numbers, or is there more to it? Let's find out. Alright, so accuracy is one of the most commonly used metrics to evaluate the performance of a machine learning model, but it's essential to understand what it truly represents. In simple terms, accuracy is defined as the ratio of the number of correct predictions to the total number of predictions made. Mathematically, it's expressed as accuracy equals total predictions. Let's break this down a bit with an example. Imagine we have a model that predicts whether emails are spam or not. After running our model on a dataset of 100 emails, let's say it correctly identifies 80 emails as not spam and 10 emails as spam. However, it incorrectly flags 5 non-spam emails as spam and misses 5 spam emails. Here's how we would calculate the accuracy. True positives, 10. True negatives, 80. False positives, 5. False negatives, 5. So, plugging in these numbers, accuracy equals 100 is equal to 90, 100 is equal to 0.90 or 90%. This means our model is 90% accurate. Sounds great, right? But wait a minute. Here's where it gets interesting. Accuracy can be misleading, especially in cases where we have imbalanced datasets. For example, if we were predicting whether a tumor is malignant or benign, and 95% of the tumors in our dataset were benign, a model that simply predicts every tumor as benign could still achieve 95% accuracy. But clearly, that model wouldn't be very useful because it fails to identify any malignant tumors. So, what can we do? This is where we need to look at other evaluation metrics alongside accuracy, such as precision, recall, and the F1 score. Precision measures the accuracy of the positive predictions. In our email example, it tells us how many of the emails we predicted as spam were actually spam. Recall, on the other hand, tells us how many of the actual spam emails we successfully identified. F1 score is a harmonic mean of precision and recall, providing a balance between the two. Let's take a look at how these metrics might play out in our spam email example. Precision equals TP equals 10 equals 0.67 or 67%. Recall equals TP equals 10 equals 0.67 or 67%. F1 score equals 2 asterisk equals 2 asterisk equals 0.67 or 67%. With these metrics, we can see that while our accuracy looks great, the precision and recall reveal that our model isn't performing as well as we thought. This highlights the importance of not relying solely on accuracy to gauge model performance. Now, let's take this a step further. In different contexts, accuracy might not even be the best measure to use. For instance, in financial fraud detection, we'd prefer to minimize false negatives, which means we want to catch as many fraudulent transactions as possible, even if it means having a few more false positives. Here, the recall metric would be more relevant than accuracy. Lastly, one more critical point to consider: the trade-off between precision and recall. Increasing one often decreases the other, which is why understanding your specific application's requirements is crucial when evaluating model performance. To sum it all up, accuracy is a straightforward and widely recognized metric in machine learning, but it's essential to look beyond it. Understanding the context of your data and considering additional metrics like precision, recall, and F1 score can provide a clearer picture of your model's performance. So next time you evaluate a machine learning model, remember, accuracy is just one piece of the puzzle. If you found this video helpful, please give us a thumbs up and share it with your friends. And if you have any questions or topics you'd like us to cover next, drop them in the comments below. Until next time, keep learning and stay curious.